today we are dedicating this show to Cody Scherf. All very concerned about, aren't we? I don't know. He's gone. I have not seen his height. So, Cody, we hope you're doing well. And this is a shout out to Brooke and to Larissa for the days that they were gone where we didn't say anything to them and we just kind of didn't notice. So, sorry to you. So, review of the chain rule. We practiced on Friday. You're really good at it. If you have f of u of x and you want to take the derivative is f prime, so the derivative of the outside with the inside left alone, times the derivative of the inside. So let's do the most basic example. 2 times 3x minus 5 to the 6th power. I like to make 4 boxes. I put the inside function here. What's the inside? What? What do I put here? And then 2u to the 6. Okay. So I have to write, so the first step is to just write these as a composition of functions. So the inside is 2x minus 3, or 3x minus 5. The outside is 2u to the 6th. Now, what I do is I take the derivative and substitute that back in. What is 2u to the 6th, the derivative? 12u to the 5th. And then the derivative of 3x minus 5 is 3. And so when you end up with those results, what do you do with them? You multiply them. So f prime of x is equal to 36 u to the 5th. And so Tyler substitutes the 3x minus 5 back in to the 5th power. So it used to be that in order to find that type of derivative, you would have to actually multiply it out 6 times and then use your power rule. Now you don't have to do that. B, what's the inside? Seven minus 4x. Okay. What's the outside? U to the 1/3. What is the derivative of u to the 1/3? How about 1 over 3 u to the 2/3 power? Now, here's where people get mixed up, and this is really, you know, if this kind of confuses you, my apologies. But you know, people when they multiply this together, they're like, you know, -4. Well, do you multiply the top or the bottom? This is -4 over 1, so it's just going to be on the top. My calculus class is getting really upset right now with problems like this, you know, where they're multiplying. They're like, well, don't you have to multiply the top and the bottom? No, you don't. That's if, you know, they're confused about what they're doing, okay? So that's just not the case. So you end up with f prime of x is equal to -4 on top, and on bottom you have 3, and then 7 minus 4x to the 2/3 power. That's it. So you can see the derivative. You know, these end up happening pretty quickly and easily. How's about letter C? I would first like to rewrite it so nobody gets confused. Negative 10 times 2x minus 3x squared to the negative fifth power, as Larry said. So my inside is 2x minus 3x squared, the outside. Negative 10u to the negative 5. So now it's time to take the derivative. What is the derivative of negative 10u to the negative fifth? 50u to the negative 6. What's the derivative of 2x minus 3x squared? So, when we multiply these together to find our derivative in the end, I can distribute the 50 to both of those and get 100 minus 300x. So that'll be my outside portion. My inside portion will be 2x minus 3x squared to the negative 6 power. So that will be on the bottom. We'll try this again. 100 minus 300x over 2x minus 3x squared to the 6th power. Okay, see if you can do the last one on your own. Try the last one on your own. Go. There you go. There's your derivative. It should be negative 40x to the fourth, secant of 2x squared tangent, I'm sorry, secant of 2x to the fifth tangent 2x to the fifth. Now again, I will get some people who will distribute that negative 40 to the 2's. You don't have the distribution. Cut off some toes if you do that. That's worse than a finger right there. So. Okay. Now we get more difficult, okay? And I'll be honest, I don't know how to teach this very well, okay? Every year I teach this, I would say probably half the students, they can do this correctly, and about half the students can't. And I don't know why. So if you have ideas as to why, then you can tell me. But I'm going to tell you right now that we'll do these examples, but for some reason, a lot of people don't see why we're doing what we're doing, and I'm trying to, I don't know why. So anyway, it says to find the derivative of the following, you may need to use more than one rule. And so for A, we do need to use more than one rule. When I say more than one rule, I'm talking about product, quotient, and chain. Now, those are the 4 rules that you have at your disposal. Oh, I'm sorry, 3 rules that you have at your disposal. I was thinking the power rule, well, as well would count as 4, but we don't really, obviously you're going to use that all the time. So we've got those 3. The question is, the first one does require more than one rule. Do you know which one? Product and chain. Now, here's the question that people always ask. They always ask, which do I do first? Do I do the product rule first or the chain rule first? And that's really hard for me to think through. I start setting up the product rule first, but I do the chain rule before I finish the product rule. Wait, let me try this. I was thinking about this the other day. I was headed off to bed yesterday, and I was like, oh, okay, I gotta teach a chain rule again tomorrow. And I'm thinking, okay, obviously they know how to do the easy ones. Never have a problem with getting people to do the easy ones, but what about the hard ones? I thought, how can I teach that so they understand it better? And so here's my one idea, okay? Here's just my one idea, okay? Let's think about x, because x changes, right? Suppose you were to plug something in for x, okay? And you guys, this is just, never taught it like this before. So if this doesn't work, don't yell at me. Let's suppose you plug in 2, okay, for x, okay? All right, let's say you plug in the 2 for the x, okay? Can you tell me the order of operations and how that will work? So you put the 2 in it, square it, then multiply by -3, right? So that's one part here, right? And before you multiply it by cosine of 4x, first you have to figure out what cosine of 4x is, right? Okay? So this is a situation where you have two functions multiplied together, and as you plug them in, you saw that you evaluated this one separately from this one, right? There's no operation that you did to both of these functions together, right? For example, like here you have a function on top, here you have a function on bottom, and in the end, both of them get square rooted, right? Okay, there's nothing that happens to both of these. So here's how I set this up, okay? I set it up as the product rule. So this is my f, and this is my g. And I set it up like this. F prime of x is equal to f prime g plus g prime f. What is f prime? Times cosine of 4x plus g prime. Oh boy. When I do g prime, then I have to use the when you take the derivative of cosine 4x, you have to use the chain rule. Okay. So what goes here? What goes here? So that's negative sine of u and 4. Multiply them together, you get negative 4 sine of 4x times f. What's f? Okay, so if you write this in simplified form, you would have f prime of x is equal to negative 6x cosine of red. There it goes. Okay. So, here's my question to you, okay? What was the, was this an example where we did the chain rule within the product rule? Or was this an example where we did the product rule within the chain rule? This was a chain rule within the product rule. The product rule was the outside structure to this problem. Okay? It was the outside structure to this problem. Now, can you see what is going to be the outside structure to this problem? You u to the 1/2. The outside structure to this problem is going to be the chain rule. Can you see what the inside structure is going to be? The quotient rule. So, and if you have trouble thinking that through, again, here's, if you plug in 2, so 2 minus 2 is 0, 2 times 2 plus 3 is 7. So then you would divide those, right? That division piece tells you you're going to use the quotient rule. And after you divide them, then you square root them. So that tells you chain rule. Okay? So quotient rule first, you divided them, then square root. That's the chain rule of the entire piece. Whereas here, you did the chain rule, then you multiplied both the pieces together. That's why the product rule is on the outside. So let's try setting up this one. So I set up the product rule for you that time, but what I set up here, what is the outermost part? What's the outside structure of this problem going to be? Product, chain, or quotient? Chain. So we set up the chain. What is the inside? 2 minus x over 2x plus 3. Now, a lot of people get mad when they see that because they're like, well, we're going to have to take the quotient. Yes, you are going to use the quotient rule for that. And we'll do it here in just a second. No. That if you use the quotient rule first, then the chain rule, well, it depends on how you're saying it. You can't... wait till we're done and then ask the question again. I don't know if I can answer it right now. U to the 1/2 is on the outside. What's the derivative of u to the 1/2? One over 2 roots of u. Yeah, now I need to use the quotient rule for 2 minus x over 2x plus 3. So what is the derivative of the top? -1 times the bottom left alone. What's the derivative of the bottom? Times the top left alone. All over better combine some terms here. Looks like we've got a -2x, and then we end up with a positive 2x, don't we? So those will cancel. I have a -3, and then I have a -4 makes, so I have -7 over 2x plus 3 quantity squared. So it looks like that's the derivative of the inside. Question? Yeah, so now I multiply these two together, don't I? And so I'm gonna write this out fully before I put it all together. I'm gonna have the -7 times 1 on the top is -7 over 2 roots of u times 2x plus 3 squared. And what's my last step? What do I have to plug in? I have to plug in 2x plus 3 into the bottom, right? So you could just leave it like -7 over 2 times the root of 2x plus 3 times 2x plus 3, that quantity squared. What did I do? Like that? What did I do? Oh, whoa. I'm sorry. Yes, thank you. Thank you. All right. I need a little bit more room here, don't I? -7 over 2 times the root of what was on the bottom? Can you leave it like that? The problem is that it's no. There's just one small step here. The problem is that you have a complex fraction now. You have a fraction inside a larger fraction. So instead of dividing by this, let's multiply by the reciprocal. Because this is just the square root of 2 minus x over the square root of 2x plus 3, right? You can take the square root of the top and the square root of the bottom. So if you just multiply by the reciprocal, you're going to get negative 7. Yeah, you can't leave it like that. Do you see what happens now? This is 2x plus 3 is to what power? 1/2. And you also have a 2x plus 3 on the bottom, right? And there's no addition in here or subtraction. So you could, if you divide these, what do you do to the exponents? You subtract. So you don't even have to have that part on top. Negative 7 over 2 roots of 2 minus x. Yeah, you're going to have to get a scratchy paper if you want it all, probably. And then 3/2. Yeah, there you go. That, yeah, that is the correct answer. Kind of challenging. Ooh. We're dividing this by this. So this is like 5 over 2 over x. And so we're doing 5 over 1. Instead of dividing by 2 over x, we're multiply by x over 2. Okay. Well, now remember, guys, this part right here was the calculus. The last part was algebra. So algebra can be challenging. Okay. Now is the most difficult one that you'll see here, okay? Let's try C. Can you tell me what is going to be the outside structure of this problem? The quotient rule will be the outside structure. And here's why, okay? You're absolutely right. This does require the use of the chain rule, but when you put something in for x, you'll take it to the 4th, right? Then you'll put something in for x, you'll take it to the 6th. And after you're all done, you will then at the very end divide them. And so since the last step is we divide it, that means that what we set up is the quotient rule. The last step is what you set up. And if you remember, we set this up as f prime g minus g prime f all over g squared. So we're true or false? We're gonna have to take the derivative of both the top and the bottom. True. And in order to take the derivative of the top and the bottom, you have to use the. So I have to use the chain rule how many times? Twice. So let's set them up quick. We'll do the top one right here. We'll do the bottom one right there. And so this is what I actually do when I do my work is I set them up on the side. So for the first one, what goes right here? X minus 5, u to the 4th, or u to the 3rd, 3. See? And all of a sudden you realize now that we can do the chain rule pretty quickly. Some of you won't even set up the boxes after a while. You'll just look at it. You'll be like, oh yeah, drop the 4. That's a 4 times a 3. And you'll go from there, okay? All right, so, and then what goes here? 2 minus x, u to the 6th, u to the 5th, negative 1. So I have my two derivatives, don't I? Okay. Can I erase this? So, what is f prime? Twelve 3x minus 5 to the third times the bottom left alone, which is 2 minus x to the sixth. This works out really nicely, everybody. Really nicely. Okay. Minus. So that becomes a plus. And then 3x minus 5 to the fourth. And that's all going to be over the bottom squared. When you get the bottom squared, what do you get? 2 minus x to the 12th. So we'll see if everybody sees what's happening here. Can you see the common factor that is shared in the numerator as well as the denominator? 2 minus x. So you're going to see a nice little trick here. Okay, this works out really well. I'm going to suggest that we take out between 12 and 6. We should take out a 6 out of the top, just out of the top. Okay, and out of 3x minus 5, how many of those should I take out? I should take out 3 of them. This one has 4 of them. So I could take out a 3x minus 5 to the third, and I could take out a 2 minus x to the fifth. And when I take those out, what are you left with right here? 2 times 2 minus x plus, and then what are you left with here? 3x minus 5. And on the bottom you have 2 minus x to the 12. Awesome. Yeah, the 2 minus x to the 5th and the 2 minus x to the 12th becomes 2 minus x to the 7th. So this will entirely go away. That will become 7. So all that will be left in the structure of this problem is you'll have this piece right here, which is 6 times the 3x minus 5 to the third. Let's figure out what this is. You have a negative 2x and a positive 3x make x. And then we have a positive 2 and a negative 5, which make positive 2 and a negative 5 make negative 1. Wait. 2 times 2 is 2 times negative 2x plus 3x minus 5. So negative 2x and positive 3x make x, and 4 and negative 5 make over yeah, that's beautiful. It's really nice. Okay, our goal is if we can finish off this problem on the backside, then tomorrow we can have a whole work day. Okay. Yeah, I'm gonna give you an assignment, but it won't be due till well. Yeah, won't be due until test day. Okay. Now we'll see here for this last problem. What's it? Not the chain rule 4 times, just the chain rule twice. Let me show you how this is set up, just so we all understand. This is the same as -8 times sine of 4x minus 2 to the 4th power. When you see this sine to the 4th power, what that means is if we were to plug in a number, say 1, we would get 4 times 1 is 4 minus 2 is 2. We would then take the sine of it, which requires the use of the chain rule. After we take the sine of it, we then take it to the 4th power, which requires the chain rule. And then seeing how you're only multiplying by -8, that doesn't require anything extra. That's just a constant. If it was a -8x, then we would have the product rule as well. So this is just the chain rule 2 times. So, what goes on the out, or what goes on the inside? That goes on the inside, sine of 4x minus 2. Not just u to the 4th, but -8 u to the 4th. What's the derivative of -8 u to the 4th? Now, I'm going to just, everybody pause. I'm just going to do this really quick. In order to take this derivative, you have to use the chain rule. Watch. Watch. Okay, just watch. The derivative of this is 4 cosine of 4x minus 2. Do you see it? So we'll go back to my language that you didn't like on Friday. Maybe some of you like it now. The derivative of the inside, which is 4, times the derivative of the outside, which is cosine, with the inside left alone. So if you don't like that, that's fine. Just set up another chain rule and do 4x minus 2, do sine of u, do cosine of u, do 4, multiply, get 4 cosine of 4x minus 2. I don't care which one you do, but my point is that you can often look at this and tell what the derivative is right away. So, okay. Yeah, exactly. This is a double chain rule problem, but this one you can do in your head. So you really, a lot of times you only set it up once then. So, at 1.5. All right, very good. So we multiply. What's -32 times 4? Okay. Times the cosine of 4x minus 2. Times u to the 3rd. What is u? Sine to the 3rd, then, of 4x minus 2. You want to write sine to the 3rd first? You can't put the 3rd here because then it would be 4x minus 2 to the 3rd. It would have to be parentheses around everything if you want to write that. Okay, let's try an easier problem. So, when you do the chain rule, it says, suppose that f of x is a composition of f of g of x. You know f of 3 is 2, g of 3 is -1, f prime of -1 is 1, g prime of 3 is 4. It wants you to find f prime of 3. So here's what I'm going to write out, okay? If I do the chain rule and I write this out, okay, I get the derivative of the outside, so the derivative of f is f prime with the inside left alone, g of x, times g prime of x. So whether you're using f and u or f and g, this is a rule that you should memorize, okay? Because you should know that this is the same thing as doing the 4 boxes. You always think of 4 boxes. This is the notation that we use. So I'm trying to do, what's that? This is the chain. So I'm doing f prime of 3. So wherever I have an x, I'm going to write 3. So I have f prime of g of 3 times g prime of 3. That's what I'm trying to evaluate. Do you know what g prime of 3 is? It is 4. Right here, you see 4. Before I do f prime of g of 3, I first have to find what g of 3 is, don't I? What is g of 3? G of 3 is negative 1. So this is the same as f prime of negative 1. What is f prime of negative 1? 1. Now it says, now we have a graph. It says, given the following graphs, u of x is f of g of x, and w of x is g of f of x. It says find u prime and find w prime. And I have my 2 graphs right here. The first thing is that I'm going to do is I'm going to write out the chain rule. U prime of x is a composition. So I will write that as f prime of g of x times g prime of x. Everybody okay with that? I'm trying to evaluate u prime at what number? 1. So u prime of 1 is equal to f prime of g of 1 times g prime of 1. So the question is, what is g prime of 1? We'll do that first. So what is the rate of change of the function g at 1? So if I go over to 1, the rate of change means the slope. What's the slope? 3. Now, before I find the rate of f, I first have to evaluate g of 1. What is g of 1? If I go over to 1, g has a value of 2, so now I evaluate the rate of f at 2. So what is the rate of change of f at 2? Negative 2. Well, now we have w. How is w different? Right, so w prime of x is going to be g prime of f of x times f prime of x. Or w prime of negative 2 is equal to g prime of f of negative 2 times f prime of negative 2. Because by definition up here it says let w of x equal g of f of x. So that's why we switched it. Thank you. So first I'll identify what is f prime of negative 2. What is the slope of f at negative 2? If I go to negative 2, f has a slope of 1. Very good. Times g prime of f of negative 2. So before I do anything with g prime, first I have to do f of negative 2. I go negative 2, and f is 5. G prime of 5 is 1/4. So, you know, raise your hand if that was a little bit confusing for you. Okay, so my encouragement to you is to go back and do the problem again without looking at how we did it. Okay, try it again. Okay. All right, last example. Find an equation for a line to the given curve, tangent to the given curve at a given point. So back to the very basic problem that we started with in calculus. We will continue to always come back to this type of problem. In order to write an equation for a line, you need two things. What are they? And point on the line. That's what we need. What's the point on the line? In order to find the slope, you have to first find the derivative. What is the derivative of 2x minus 3 to the fifth? What do you have to use? Chain rule. Some of you can do it without setting this up. Get it? Good job. So you get 10 times 2x minus 3 to the fourth power. What number do you plug in? You plug in 1 because that's where you're evaluating it. So we plug in 1. 2 times 1 is minus 3 is negative 1 to the fourth is 1 times 10 is slope is 10. Y equals mx plus b. Y is negative 1. M is 10. X is 1. Piece of cake. Upside down. Okay, we've got 50 seconds to write your assignment down. Perfect timing. You guys have homework that's starting to build up, don't you? You can do it! All day tomorrow to work, folks! You're the best!